All right, this is 7th grade lesson 3.3. The students will use multiplication as well as division and cross-product properties to decide if two ratios are equal. The standards covered in this lesson are 7 RP 2A. The page numbers out of the hardcover book are 110 through 115, and out of the practice journal, pages 63 through 66. Today we're going to be working with proportions. A proportion is an equation stating that two ratios are equivalent or equal to each other. The two quantities that form a proportion are then considered proportional. What we're going to start working with to begin with is deciding whether two sets of rates or ratios are considered proportional. So it's kind of looking at two fractions and asking if they're equivalent to each other or equal to each other. Two ratios are proportional if their reduced ratios are the same, if their decimal form, if you were to change them into a decimal, is the same, or if you check cross products. So cross products is probably something that'll be new to you. So for example, if I started out with this set of ratios, I've got 2/3, and is that equivalent to 4/6? So there's a couple different options that you could do. You could make equivalent fractions. So somebody may look at this one and say, hey, 4/6 would reduce down because 2 would go into each of those. And this would become 2/3. So now is 2/3 equal to 2/3? Yes, it is. Then we would say, yes, this is proportional. Okay, so that's one method. Somebody else may have also said, hey, I want to make them equivalent, but instead of reducing them, I'm going to change this front fraction because if I took 2 times 2, I could get 4. So then I would have to go times 2 on this. Would that give me 6? Yeah, it would give me 4/6. And here we ended up with the same fraction. So once again, yes, it would be proportional. Okay, so that's doing equivalent fractions. There's also the method that you could go through and change each of these into their decimal form to check them. So of course you can use a calculator on this. I'm not checking your division, but when we read this fraction, it would be 2 divided by 3. So top to bottom is the way that you would type it into your calculator, 2 divided by 3, which would give me 0.6 repeating. Okay, if I did the same thing with my 4 divided by 6, 4 divided by 6, it gives me 0.6 repeating. And you'll notice that, yes, once again, those were the same decimals. Okay, the new concept that actually we'll tie into a little bit more in our next lesson is when we're finding missing parts of proportions, we'll have to understand cross products. Cross products are when you can take a number, a set of fractions, and you can multiply diagonally. So when we go through to do this, 2 times 6 would give me 12. And 3 times 4 would also give me 12. So we're going to do cross products there. Eventually we'll call this cross multiply and divide, or cross multiply and solve as you get older. But this, because we ended up with the same cross products, then yes, they are considered proportional. So notice that we went through 3 different ways that we could actually go through and decide whether or not a set of ratios were proportional to each other. So I want you to let's try this one. Okay, and you can decide, do I want to do equivalent fractions? Do I want to go through and change them to decimals? Do I want to check cross products? Okay, and any of the methods should give you the correct answer. So if I go through and do this one, I'll do cross products. So 4 times 8 is 32. 12 times 6, I can already tell, is going to be way over 32. That would give me 72. And that's without me even going through and using my calculator. I could tell if it was 10 times 6, that would give me 60. This would be a no. Okay, if somebody changed it to decimals, well, 6 divided by 4 gives you 1.5. And 8 divided by 12 gives you 0.6 repeating. Not the same. Somebody else might have just looked and said, hey, we have an improper fraction versus a regular fraction. There's no way they're equal to each other. All right, how about this one? Go ahead and try this one. One of your methods. It doesn't matter if you do cross products, decimals, or equivalent fractions. So go ahead and try this one on your own. This one, just in case I didn't have a calculator, this is what I'm going to do. I'm going to divide by and reduce the fraction. So like here, if I reduce, 3 would go into each of those. Now, somebody that doesn't like to find a number that's common between them, then they wouldn't like this method. Okay, so if I go through and do this, I would get 5 over 4. And here, if I divide, 5 goes into both of them. So 25 divided by 5, I'm going this way, by the way, would give me 5. 20 divided by 5 would be 4. I get 5 over 4 for each of them, so this would be a yes. Okay, somebody that doesn't like to reduce fractions, or that's something that they struggle with, I would recommend checking the decimal. Punching it in as 25 divided by 20. You get 1.25, and then 15 divided by 12. You get 1.25. Cross products will also work. 12 times 25 gives me 300. Okay, 20 times 15, 2 times 15 is 30, add a 0, still 300. Okay, so there's lots of different methods. You have to find what you're comfortable with. And sometimes one method's easier to do just based on the numbers that you have. Okay, so I want you guys to try this one on your own, as well as this one. And I need a equal sign between these. Okay, so go through and check those two. So you can pause your video so that you've got time to work. Go through and check those two and see if they are proportional to each other, or if they create proportions. Okay, so you should have ended up with a no and a yes, just depending on what you did. But either way, whether it's changing them to reduced fractions, changing them into their decimal form, or checking their cross products, you would note that on the first one, we did not get the same numbers, and on the second one, we did. So that's working with deciding whether something's proportional or not. So now we're going to go ahead and work with some word equations where they're asking us the same thing. Tell whether the two rates form a proportion. So here we have a scenario where it says 66 wins in 82 games. And is that equivalent to 99 wins in 123 games? So when you work with a word problem, you are going to work left to right is top to bottom. So here I've got wins would be my top over 82 games. Now, if you're just checking proportions, it wouldn't matter if you did that order. If you had flipped it around, did 82 over 66, that would be fine. But then you have to make sure in your second proportion that you match labels. I just like to work left to right because when I'm doing rates, that's usually how it's set up. So then here I would do 99 wins over 123 games. Okay, so now if I go through and it doesn't matter, decimals, cross products, I'm going to go ahead and do decimals on this one. So if I do the decimals, 66 divided by 82 gives me 0.804, and I'm going to write multiple just in case they're close. 99 divided by 123, 0.804. Okay, so I ended up with the same ones. So they look like they probably are, but I'm going to double check myself just by doing cross products, because then I don't have to compare all those decimals in my head. So if I do 123 times 66, it's going to give me 8,118. Okay, if I do 82 times 99, I did get the exact same answer. To me, it's just easier to compare this versus those really long decimal numbers. Even though the first 3 digits were the same, you never know if you get a long decimal number, if it changes further back, unless you write it all down, and that's kind of time consuming. So in this question, were the rates proportional? This would be a yes, they were proportional. Okay, so let's try another one. Okay, 440 calories and 4 servings. So 440, and that was my calories per serving, and then over 4 servings. And is that equivalent? So my 300 calories has to go on the top over 3 servings. So I can either check cross products, I can check the decimal form, I can reduce fractions. Here I would get 1,200, and here I would get think 1320. 440 times 3 is 1320. Are those the same? No. So this would be a no, they are not proportional, or they do not form a proportion. Okay, so I'm going to put one out here for you guys to try. Okay, 7 inches in 9 hours and 42 inches in 54 hours. So I want you to go ahead and work your way through this one. You need to set it up as proportions, first of all, so those fractions, and then check to see if they're proportional. You should have ended up with a yes on this. Okay, so that's working with some basic word problems. Now I'm going to give you where they're going to give us story problems. So it's still the same thing. It's just that they're kind of putting it into a scenario. Okay, so I've got, you swim your first 4 laps in 2.4 minutes. 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So here, I'm going to go ahead, number of laps proportional to your time. So if I go through and set it up as proportions, it's not going to matter the order, but whatever order I choose in the beginning, I need to then do the same in my second setup. So if I set this up, if I did laps per minute, 4 laps over minutes, so 2.4 minutes. And then that means that in my second proportion, I need to do my laps first, 16 in 12 minutes. Okay, just making sure that you're matching your laps in the same level and your minutes in the same level. If you had them flipped over because you wanted to do minutes per lap, you'll notice here, I'll flip it over, that we should get the same answer either way. So in my first scenario, it was 2.4 minutes per 4 laps. And then, whoops, I better leave that off because I didn't put my label in the first one. And then in the second situation, it was 12 minutes for 16 laps. So either way, you're still cross multiplying the same numbers. See how we're still doing, if you're doing cross multiplying, 12 times 4 is 48, and 2.4 times 16 gives me 38.4. Okay, so in this situation, are they proportional? No, they're not the same. Okay, so this would be a no. They are not proportional. Okay, so I'm going to go ahead and give you guys one to do because it's the same thing. It's just giving it more into a story problem. So go ahead and try this one. You can do 90 sit-ups in 2 minutes. Your friend can do 135 sit-ups in 3 minutes. Are these rates proportional? I personally would do like sit-ups per minute, but if you want to do minutes per sit-up, kind of a strange answer, but I would do sit-ups as my top number and minutes as my bottom number. So go ahead, pause your video and work your way through this one. So you, oh, whoops, sorry, I wrote that wrong. This should have been a yes. Because you ended up, if you reduced them down, you had 45 sit-ups per minute. In both situations, cross products, you end up with 270 for each one. Okay, that's pretty much it for this. The key thing on proportions is to make sure that if you're working out of story problems, you're matching labels and you're setting up your both scenarios in the same order. Otherwise, remember, you can check to see if they're proportional by changing them into decimals, changing them into equivalent fractions, or checking your cross products.